Welcome everyone. Welcome everyone to this session where we'll be discussing and learning about non-operational quality attributes of embedded system. As you can see, there are five non-operational quality attributes, that is testability and debuggability, availability, portability, sorry, portability, time to prototype a market per unit, and total costs. So let us see the notes which I have prepared for the channel. Basically, it's nothing but the filtered version of the textbook, so you don't have to worry that the things will be different from the textbook and here. In the textbook, it's like massive content and too much, big paragraphs which are difficult, obviously to read everything. So here it is filtered with examples and all the basic definitions. So what are the non-quality operational attributes? These quality attributes focus on aspects of the embedded system that not related to its direct operation behavior. In operational quality, like direct, specific purpose is there for the, operation behavior, like it's specified. Particular operation itself, it is built for particular operation, like performs particular things. But here is non-operation, like it's not directly related to the operational behavior, but rather on factors affecting the product's life cycle, development, and usability outside real-time functioning. So it's like mostly about production and manufacturing type, and the operation quality attributes are mostly based on real world application. This is for production and marketing things. The first thing is testability and debuggability. What do you understand by the word testability and debuggability? One, testability in the sense about testing, and debuggability is about debugging. But how, where, and what, why, that will understand. Testability is nothing but the embedded system, whatever it is, manufactured or created. It should be easily, how easily the embedded product can be tested to ensure it functions as expected. It's nothing but ease of testing the product within a time. So you can see ease of testing and debugging the system during development. So ease of testing of the embedded product during the development. You can also talk about hardware testing and firmware testing. Hardware testing is nothing but for peripherals and to check whether the hardware is working properly or not. Firmware is about how the software behaves. Debuggability is same ability to find and fix faults causing unexpected behavior during the development. Okay. Here again you have hardware debugging and software debugging. Hardware debugging is nothing but trying the fixing physical issues. In firmware debugging, it's nothing but bugs or any other logical errors in software. So hardware for hardware, firmware for software. Okay, I hope it was easy. Sorry for my language. I'm just taking a lot of pause. It's just common during explanation. So I hope you understood the concept of first thing, testability and debuggability. Ability. Second one is evolvability. It's nothing but with the time, how the time passes, the system should be capable of adapting to update itself for for the latest technology and future use. Derived from biology, the word you can simply say ease of modifying the embedded system. So you have to always mention ease of doing. See, in testability, ease of testing and debugging during the development. Here, ease of modifying the embedded system, the hardware or the firmware, to incorporate with new technologies or improvements for future. See, important for long-term product relevance to upgrade future. See, ease of modifying or upgrading the system in the future. Right? There should be ease, portability. Measure the system's independence from specific hardware platforms or operation. It's basically that embedded system shouldn't work on specific platform. Either it is an hardware platform or a software platform. It shouldn't be like specific to particular platform. Like it should be like working on multiple hardware platforms and multiple software platforms. That's what they're talking about portability over here. Take an example of C and C, real analogy. Desktop apps in Microsoft Visual C++ run only on Windows, while Java apps run across platforms supporting Java, like mobile, Android, iOS, and etc. etc. If you see here, ability to transfer the system to different hardware or software platforms. I hope you understand. You can use the example of any application which runs only on specific software, like Windows they have given over here, and you can take another example to counter the previous example, saying it can run multiple platforms, and one is running only in Windows, another running in across multiple platforms. Time to prototype and market, in the sense what the time duration between prototyping and marketing, in the sense duration between the product idea and the product's availability. When did you start? When did you start to develop the idea for the product, and when the product was available in the market? You understand, right? So suddenly I got an idea to create a product. So now I'll note down this idea. Suppose it's like January 1st, and the time the product was in the market was 6 months later. 7th. I think it's August. So not August, July, right? May, June, yeah, July. So July for like that 6 months. That's the time to prepare a market. So prototyping is nothing but creating a basic model which highlights all the features and stuff. That's nothing but prototyping. Not much things are required. Although if you don't have much words to write and it has been asked for more marks, you can simply use a real world example with technical terms in it. Okay, you can say time to market over here. Time to market, time required to develop and release the product, not much different. Per unit cost and revenue, in the sense, they are speaking here that cost is important for both user and the seller and the buyer, and it has to be balance the cost between budget and marginal profit. It shouldn't be like you have put a lot of budget in building the system, but you're getting the profit is too less. Like it will take years, like 10-20 years to collect back the amount you have put in budget. It's like that. Proper market research and cost benefit analysis are essential to set up competitive and yet profitable price. Small thing how to talk about is cost of manufacturing each unit is crucial in consumer electronics. They're just talking about how much cost should be used for manufacturing the each unit. It shouldn't be too much. It should be like per unit cost should be less and the profit should be more. It's just about that. Product life cycle PLC. Okay, so this should be the last. It's not included inside this, but you have to. They might separately ask about this. For better understanding, you can see the you know textbook part. Why textbooks are there? See, it has five sections: product development, introduction, growth, maturity, and retirement. Everything is about product based on revenue and time. So they might separately ask about this particular PLC, or they might ask about that complete non-operational quality attributes. So you should be prepared. See, product development, introduction, growth phase, maturity phase, decline, retirement phase, unit cost, profit. It's just five things you have to remember about it. See, in the development, you are just designing, prototyping, and development. Investment phase with no revenue. Okay, so just like putting money, but you're not getting any return in this. Product introduction, initial market launch. See, it's nothing but launching the product to the market. Low sales and revenue. Growth phase, sales increases rapidly because you are just introduced, right? Obviously there won't be, for example, if I have uploaded my video in the YouTube, there won't be instant high views for my video. Like there will be only 1 2 3 for many days, and before exam it will go more than 100, sometimes more than 1K or like that. That's growth phase. Maturity phase, it's nothing but sales stabilize, peak revenue, where you are getting it's like constant and you're getting proper revenue and all. Decline, retirement phase, nothing but sales, market share, and revenue decreases. Like it's not trending a lot. Maturity phase, growth phase is trending phase. Maturity is like constant. Decline, retirement phase is like not trending anymore. Unit cost is highest during introduction and decreases as production sells. Profit starts negative due to development cost, rises during growth. So you can understand, see, profit, this line is there, right? It's negative because you have invested a lot at that time, you don't have any profit. Since you have introduced it, now it's like in the growth, it's the peakest at the growth and between the maturity phase. Now with time it decreases, just like that. So that's all about this part. You can see conclusion. Always mention a conclusion. Domain specific examples if you want to know. See, automotive systems, relevant quality attributes. Example, medical devices, consumer electronics. You can just pause and see about this. Example use in answer. Okay, example use. That's all about this, and I don't think much is required over here. Thank you, and we'll see in the next video talking about, I think, applications. What will we talking? Operational and non-operational is done. See, almost half is done. Applications. Okay, we'll see in the application section. Bye bye. There's also this summary for the section 3.2.2. 3.2.2 is nothing but mentioned in the textbook. So this is like table type of explanation given in this small definitions which you can suppose you have given a small content, you can simply make this table at the end showcasing like very qualitative high quality words as a description and importance everything. If not, you can simply whenever you like talk about this, you can give a description, importance in one line, and then example in another line. So like three types of thing. For few things it was done in the same way, I guess. Not for this. Key measures example here, definition, threads, like you have to just make in such a way that everything is like covered, like it looks professional and all the words that these notes are made based on the Bloom's taxonomy level, that or else you call them as RBT level. I'll show you, they are mentioned in this, right? L1 and only L1 and L2 are there. So in few notes I've also included L3 and L4 which are nothing but high level of answering things. Since it is L1 and L2, you don't have to worry much. L1 is like basic remembering, and L2 is like comparison differences type. Each topic is answered and prepared in such a way like that. So key points and definition in non-operational, all the small things, potential exam questions. This all will be available in the description for the video. If it is not updated right now, it will be updated after a few time, or you can comment down for that. So there is a quiz also which you can like see what does the non-operational quality attribute portability primarily refer to. So speed of execution, ability to run different hardware process, cost of the product, or time taken. So obviously it's this, right? I won't mark this in this, so that you can just see, because if I mark here and if I save this PDF, I have to like actually upload the same thing. So I'm gonna upload the same PDF in which I have used all the highlights and stuff. So this is on you. 6 things are there, and we'll move to chapter 4 in the next video. Okay, see you there.